up your questions and stuff like that. That'd be the only other thing. The reason I record all the classes is that means if for some reason you're sick, you can't come to class, you miss something, you can easily go back to my website, click on it. It's linked up on YouTube, so it'll work on any device you have, and you can watch the class again to get more information or those type of things there. Okay, so it really does give you the ability to easily go back and review things that you might have missed in class. Okay, any questions with that? All right. Up on my website also is the syllabus. So if you click on the syllabus, you will see this. We'll go through the syllabus really quickly. I didn't print them all out because normally you guys just throw them away or don't keep them anyway. So there was no point in me wasting a bunch of paper. It's all online. You guys can access it there. I'm here every Monday and Wednesday from 8:30 to 1:30 before class. So if you do need extra help and stuff like that, just feel free to email me or tell me, and I can tell you where I am, and you can come up and get extra help. Okay. You do need the Discovering Statistics book with the access code. We're not using Ruggiero, but it comes with it from the thing. So if you buy it elsewhere, you do not necessarily need the Ruggiero code. I'm not going to use that website. You just need the actual Hawks code. All right, the most important thing that everybody's always worried about. How are you getting graded? Every lesson in Hawks has an assignment that you're going to be doing in Hawks. That's 20% of your grade. Okay, I do drop a few of them, so if you don't do them all, a few of them do end up getting dropped. I believe if I remember right, Hawks, it's based on mastery, so it's basically 100 or a 0. So as long as you've done it, you get 100 on that assignment. So it's not like, oh, I got 6 out of 7 questions or whatever else. It's you've mastered it or you didn't master it. We'll have 3 tests in class. Each one's 15% of your grade. The final exam is 25% of your grade. And participation is 10%. As long as you don't totally make me mad, you get the 10%. So the only reason that's there is so people don't just show up for the tests and nothing else. So basically everybody gets the 10%. So I wouldn't overly worry about that. All your homework's going to be in Hawks. All the tests actually will also be done in Hawks. You'll be doing them in here on the computers. If you bring your own computer, feel free to use that. That is fine. If not, you can use the computers in front of you to actually do the tests there. That allows you to get instant access to your grades, which is kind of nice. As soon as you're done, you get the grade. I will go back and look at them afterwards. So if you do up your work, you can hand in your work, and I will go back and give partial credit afterwards on the tests. You will have practice tests for every test in Hawks. So the first test will be chapters 1 through 4. I will have a practice test in Hawks for chapters 1 through 4 that's identical. So you can do that as many times as you want before you actually come into class to take the actual test. So you can practice before you take the test. Homework is due at the end of the semester. So if you fall behind on it, that's fine. You can catch up before the end of the semester. I don't look at that. I will put the grade in when you do your tests, but that grade will change every time depending throughout the semester. Your final grade will be what's all the homework you've done by May 16th, and I'll do the grades right after that point. So you don't have to worry about asking, saying, oh, I didn't catch up on the assignment. Can I turn in late? Yes. Finish the homework when you have a chance to finish the homework. Any questions with that? Yes.
For the practice test, will they be graded and handed back to us before the actual test?
You're doing it right in Hawks.
Oh, okay.
So you'll get instant feedback. Like as soon as you do the question, it'll tell you if you got it right or wrong. So, and if you have a question on it, you can feel free to email me or text me and I say, I really have no idea why I'm getting this question wrong, and I'll explain to you how to get the question right. All your tests, you're also allowed to bring in an index card. So if you have certain things when you're going through and doing the practice test that you have to constantly look up, write it on the index card. You can bring that into your actual test and use that on the actual test. Okay, so you will all have access to that. Any other questions? Yes. It will be helpful, but you can actually use one online. You don't necessarily need to buy one, so you don't go out and buy like a TI graphic calculator or anything else like that. Most of the times, I'm actually going to show you how to use using Desmos, the online calculator in class, which you'll be able to use on the tests as well. So Basically, the day before, when you're going to do the test, I will have a list of the links of the calculators and stuff that you can use on the test on my website. So you can just go there, click on the few things, and be able to pull them up. Because there's a few other statistics calculators and stuff like that as we're going through that I'm going to have you guys use. Because I can make you do it all out by hand, but that would be just torturous and not really useful. Because when you leave here to do any of this in the real world, you're going to use an online calculator to do it. You're not going to do it out by hand. Even I don't do it out by hand. So there's no point in that respect. Any other questions? Okay. Let me just show you Hawks really quickly. So when you go into Hawks, you're going to create an account. It doesn't matter which email address you use for Hawks. You can use your personal email address. You can use your school email address. That doesn't make a difference. Once you create your account and log into it, you're going to click where it says Add Course. And this will come up. Type in Three Rivers. Should show up there. It's the 3rd edition book, not the integrated review book. You'll find my name, and you'll find the section. And then you literally hit continue. And that adds the course to your list. Once you've added it, I've already been enrolled in it, so I can't add it again. It'll ask you to put in your access code. If you don't have it, that's fine. You can't say, I'm going to get it later. It'll give you 14 days or 2 weeks to get that code. Okay. So as long as you get it before the time runs out, nothing disappears. You just put the code in when you get it, and you'll access it there. If there's any other issues, questions, concerns, or anything else like that along those lines, just send me a quick email or talk to me after class, and we can work some stuff out and get things fixed up. Okay. All right. So you do not need the physical book. All you need is the access code. So, all right. Any questions with any of that? Okay. Let's get into statistics then. So first and wonderful question. How many of you are here because you actually want to learn about statistics? And how many of you are here because you were told you have to take a statistics class or a math class? So how many are here because you actually like statistics? Awesome. That's about right. How many are here because you have to be here? Sounds about right. Okay, good. All right. So, that's fine. Totally expected. Like I said, I've taught math for a long time. That's normal. The one thing I will actually say, I'm hoping that you get out before the end of this class, is that you actually see a use for statistics, so that it's not just a total and utter waste of your time that you're here just because you have to be here. So when you hear statistics, what are some of the things you think of? Yeah. Yep. Lots of percentages. Going to do lots of stuff with percentages. What else? Yeah. Yep, we're going to see some graphs. We're not going to use as many graphs as you think we're going to use, though. So, yeah, what else?
Showing data in general.
Yep, it's basically tons and tons and tons of data. So, give me some examples of data. Yeah. Okay, we collected a lot of information from surveys. What else?
Sales.
Sales, yep. Any kind of sales data, numerical data. We do a lot of that. What else? Yeah. Sports, especially baseball. Baseball is huge with statistics. Sabermetrics and stuff like that is all statistics based. They did. Yep. Oh God, I can't remember that. Moneyball. I was trying to remember that. I was like, nope, it's not that one. Yes, Moneyball. It's funny. I read an article the other day talking about that, where this person applied to, I think it was the Cincinnati Reds, and he wanted to be a statistician for the baseball team. This was back in the early 90s. And he had a letter that they sent back to him, basically denying his job request, saying that they don't really use that much statistics in their baseball team and that they don't need his services. And like 6 years later, every baseball team wanted statisticians. So, yeah, it was quite interesting with that. Not that any of you, I think, are going to go out and be statisticians, but which jobs do you think use statistics? Accounting uses a lot. The medical field uses a ton of it. Not as much as you would think. Like if you're going to go out and be a nurse, you're not going to be using statistics on a daily basis sitting there like at your job, but statistics do influence your job a lot. Okay. What else? Security. Again, like scheduling and those type of things and looking at what type of profiling and that type of stuff. Absolutely.
Insurance companies use it to see what they want to cover.
Yep. Actuarial sciences is what the insurance companies typically use. Actually, probably one of the best jobs you can get as a statistician is an actuary. Like you can make millions of dollars being an actuary. It's probably one of the best jobs to get as a mathematician. But statistics really influences pretty much every job now. So when we're looking at how data is used to figure out like how many people we're scheduling or what type of person would be best for this position, those type of things, that's all statistics and everything else that we're looking at. And even if you don't think you're using statistics, statistics is driving what you do on a daily basis. So when we're looking at insurance and those type of things, it's deciding how much you pay, how much like things that they're going to cover and those type of things. It's all there. So it really does impact us on a daily basis. The next thing that we're looking at, or when we're looking at data, is how much data is collected on us on a daily basis. So how many in here has a smartphone on them? Okay. How many sensors do you think are on your smartphone? Yeah, there's probably about 100 different sensors on your smartphone. And every one of those sensors is collecting data all the time. It's collecting temperature, it's collecting body, it's collecting everything. Okay, even stuff that you wouldn't think it's collecting. The radios, when they're on, they're looking for Wi-Fi signals, cell phone strength signals, and those type of things. That's actually how it figures out where you are most of the time. So when you're inside of a building, you can't get GPS very easily, but it uses the Wi-Fi, and it knows the strengths and stuff like that based on the Wi-Fi to figure out where you are inside of buildings and whatnot. So any type of social media you use, the reason social media is free is because you pay for it with your data. Everything you post, when you're scrolling on Facebook or scrolling on Instagram or anything else, if you pause for just a second on a thing, it knows that. And then it says, oh, they like that. Let me give me more of that. So the data that we have today that they talk about as a data explosion, it's just a massive amounts of data that we have. And it's all being collected, all being analyzed, and all designed to get you to buy things, because that's what it is. It's literally trying to make money. And the only way they make money is to get you to buy things. So that's the biggest way we're using data today, okay, is to influence decision making. All right. See, that's not what I wanted. That's what I wanted. Okay, so let's look at, so when we're starting to talk about data and information and statistics and stuff, the hardest thing that that you're gonna need to know is there's a lot of vocabulary that goes along with it. So the beginning of this class, basically chapters 1 through 4, is gonna be a lot of like names and words and definitions and those type of things, because when we start to look at the data, you need to understand what we're talking about. So the first word that we're going to learn is population. So a population, is that the right one? Yeah. Is the total set of subjects or things we're interested in studying. So give me an example of a population. What about the school? You have to be a little more specific in the population. Okay, so that wouldn't be a population. That would be a data point.
Student population, teacher population.
So students, that would be a population. Okay, not necessarily the population of students, like how the number of students in general would be a population. That's something that we can study. That's something that we can collect information on. So population is things that you're looking at that you can collect data on. Okay, so it's a little more broad than a specific data point. Those are the actual pieces that are the things, but the population is a general and whole, as a whole. So when we're yeah, I can speak, I swear. Population is a general term. Okay. Typically, when we're looking at populations, you're not going to be looking at the entire population. You're just going to be looking at pieces of it. And I'll give you the definition for that in a few minutes. Frame is there. It's not something we're going to use very often. Frame would be the list of all the members of the population, right? Which in most situations is very difficult to do. Like if I wanted you to list every single student in the entire school, that'd be very hard to do. Okay, because they're large populations or large number of things in the population. In the United States, something's done every 10 years. What is it? It is a census. The census is a survey of the entire population. Okay? So the goal of a census is to find out all the information that I need to know about the entire population. That is why it's done every 10 years. And that is why when they do it, they need to talk to everybody. So in 2020, when they sent out the surveys and everything else, to help everybody's houses and whatnot, everybody had to fill those out and send them back. Otherwise, they sent somebody to your house to ask you that information. And that's because as part of the Constitution, we need to have that information every 10 years to verify the number of people in our population, where they live, and certain demographic information about that. The main reason is that's how you determine apportionment for voting. Okay, so the population in the states determine how many votes they get in Congress and the Electoral College. So that decides that. That is the reason we have a census. We collect a lot more information now than they ever have under that census, but that is the piece of information that we need to know. Is basically the number of people. The parameters are pieces of information about it. So now when you were like, you're asking, saying like which classes they're in, stuff like that for students, that's a parameter. Okay, what is another parameter of a student?
Grades.
Their grades, what else? Huh? Age, yep. What else? Huh? Their majors. Yep. Yep, full-time, part-time. So it's like these are all different pieces of information that we can collect. All right. You could collect heights, you could collect weights, you could collect shoe size, you could collect hair color, you could collect, doesn't matter. It really depends on what you're looking to study. Let's say you're doing a study to determine if hair color determines the grade GPA of a student. Is there a connection between hair color and GPA? Okay. I don't know. I haven't done the study. You would probably think there wouldn't be, but I don't know. So that's the thing. It's like when you're looking at statistics and data, you can do anything with it. It's like if somebody's going to pay you to do it, that's the question. So there's studies out there that determine if the color of your car has an impact on the number of tickets you get. Is it the color of the car, or is it the type of personality of the person who buys that color of a car? Like there's things. So it's like we have those major conversations and stuff like that around statistics. Hello. All right, so here's some parameters of a population. There's a wonderful word, percentage. So in this case, so give me an example of what do you think the population we're studying is, if these are the parameters for. To be eligible voters. So anybody who's registered to vote. Okay. It could be just the entire population of the United States too at that point. It's like we don't necessarily have to say just eligible. Like the first question was percentage of eligible voters who will do it, but we could be looking at the entire population as well. Right, but these are just different things that you can ask. Those are what the parameters are. All right. Is it easy to ask every single person in the United States these questions? Why? Huh? This is true. But a bigger reason why would be there's 350 million people in the United States. It'd be really difficult to ask all 350 million people what they think. We actually do that once a year or on election day. That's when we actually do that. Every person, one vote. That's how we determine our elections, but that's the only way for us to find out that information. Now, so we can't ask all 350 million people who they're going to vote for, or why they're going to vote, or any of those other questions. But up to an election, we always have all this information coming out of how people are going to vote, right? How do they get it? Okay. So how many people do you think they would need to ask to determine the voting for the entire United States? Okay, so 1%. So 1% of 350 million is what? And they're like, I thought we weren't going to have to do math today. What's 1% of 350 million? 3.5 million. Okay. How easy would it be to ask 3.5 million people a question? Definitely easier than asking, but how long do you think it would take you?
Depends how many people there are asking the question.
Okay. How much do you think it would cost you? A lot of time, and possibly a lot of money, depending on how many people are asking the questions, right? The more people, the more money it's going to cost you. Okay. So 3.5 million people might still be very difficult to be able to ask those questions to. Okay. How many times over the past year have you answered a survey? Anybody answer more than 10 surveys in the past year? How many of you in here have answered any surveys over the past year? How many of those were somebody that called you up and asked you questions? So they were just random surveys that you saw online and filled it out, right? Okay. Who do you think is most likely to answer the phone and answer questions that somebody's asked?
Someone getting paid.
Somebody getting paid. Okay. It's a possibility.
Oh, you mean like if it's a product I like? Like if it's a product I'm into, I'm gonna answer your survey. But if it's just
But I'm just going to call you. I'm going to randomly call you. The phone's going to ring. You're going to see a number. Would you answer it, first of all? Okay. Okay. So let's assume, so that eliminates quite a few people, right? Because the vast majority of us don't answer the phone if we don't know the number anymore. But let's say you answered the phone and they say, hello, I'd like to ask you some questions on the upcoming election. Are you going to answer the questions? You're going to hang up the phone. Yeah. So that eliminates the vast majority of you now. Who is the most likely to actually answer those questions? Yes. Sound totally bad with this. Yeah, it was old white ladies that are sitting around doing absolutely nothing. They're going to answer the phone. They're going to talk to you. All right. So think about now. If those are the ones that are going to be answering the questions, right? Do you think that their answers reflect your opinions? Okay. So how do you get your opinion known by the people that are asking the questions? You have to answer the questions. Okay. So if you're thinking about data collection and information, okay, we decide a lot of things based on the data that's collected. Okay. So if your data is not collected and understood, you don't have a say in what's going to happen. All right. Which means things could happen that you don't agree with. Okay. So the one thing I will say, now I don't expect the vast majority of you to start answering the phones every time somebody random person calls you, because I don't even do that. However, if you do answer the phone and they're asking questions, answer them. It's 10 minutes out of your day. But the amount of information that they collect, and actually that goes into those surveys that your politicians and stuff look at. And that makes some very long-term decisions. Okay. So it is important for you to get your viewpoints out there. Now, let's take the surveys that the majority of you do answer. When you see something pop up on TikTok or Facebook or Instagram and everything else, like, do you think this? And you answer the survey. All right. Do you think that is a statistically valid survey? Do you think that's a good way to collect data? Okay. You said something before. If it's a product you like, you're more than willing to answer the question. If it's a product you hate, are you more than willing to answer the question? Yeah, because you're going to go the other direction, right? Okay. If it's a product you really don't care about, are you going to answer the questions? No. So the two groups of people that are most likely to answer those type of surveys are the ones that really are interested in it or really hate it. Okay? You're not going to get much in the middle. All right? So, again, not really good data. It's collection, it's information, but you have to take that with a grain of salt. It's like, okay, is this good information? Right? So when we're doing those surveys, we're going to look at going forward, not today, but we're going to look at how to do those surveys and how to actually get good data. Okay. And as crazy as it's going to sound, so we're thinking like, well, how many people I would have to ask in the entire United States to find out how the United States is going to vote? It's about 3,000 people. I can ask 3,000 people in the entire United. Actually, it's typically less than that, but we'll go with about the 3,000 people. I can ask about 3,000 people in the entire United States, and I can figure out what everybody in the United States is going to do. Out of 350 million people, 3,000 is all I need. It's crazy, huh? I just have to ask the right 3,000 people. That's the key. I have to ask the right 3,000 people. Those 3,000 people have to be representative of the entire population, which means I need a certain group of young people. I need a certain group of older people. I need a certain group of people that are Black. I need a certain people that are women. I need a certain people. Like, it needs to meet the demographics of the population. That's very difficult to do when a lot of people don't answer their questions. Okay. So when a bunch of people don't answer the questions, they have to go with what they have. And in their actual reports, they will write out this, like, this is what we've got, but they might not have hit every demographic group. And that's why we see a lot of times polls don't represent what ends up happening, because a lot of people don't answer them. Okay. Now, when we're asking small groups of people, those are known as samples. Okay. The sample has to be a good representation of the larger group. So if I wanted to do a survey of Three Rivers College of all the students, and I wanted to take a sample, and if I took in sample, basically just asked you all the questions that were in here, is that a good representation of the entire student body? If I just asked you guys,
Yeah.
Why? Well, believe it or not, you don't need to ask many. So like I said, I only need to ask like 3,000 people for the 350 million in the United States, right? So if I wanted to actually do a survey of the entire population here, maybe a couple hundred is all I would actually need. But ignoring the fact that there might not be as many, why would me just asking you guys not be a good representation of the entire population? Yeah. Yeah? What time is it? Right now. 2:30. There's a group of people who are typically take night classes here, right? Because they're working right now. So I would miss that group of people that have full-time jobs and stuff like that, which a lot of times are your older population that come at night. I miss those. It's also 2:00. Most of the kids who just got out of high school and stuff like that might be taking earlier classes, and I might miss them. So we're not going to get that full demographic situation. A lot of you guys are probably in specific majors because not every major has to take statistics. A lot of you are in the healthcare field and the nursing programs and stuff like that because you're told you have to take this class now. So I'd be missing groups of populations who don't have to take statistics, who might have to take the calculus classes and those type of things. So when you're looking at a sample, it's got to be representative of the larger group. That's the hardest thing to get. Okay. Remember how we had the parameters for the population? Well, a sample, we have the statistic. We call it a statistic because it is a information about the sample that we then use statistics on to find information about the population. Yes. Huh? Yeah, sure. You don't have to ask it. You just- So the concepts of statistics is to take information that we gathered about a sample and determine something about an entire population. That's the point of statistics. Determine what's going to happen if I was to do the entire population. Anybody ever had their favorite TV show canceled? So it's happening less now, but you used to have something known as the Nielsen family. So back when we actually had cable boxes and stuff like that, and we actually had only TVs and stuff in our houses, they actually would ask 500 people, 500 families around the entire country, and they would give you a box that attached to your TV. And wherever you're watching TV, you'd press your number. And those 500 families would determine what everybody watches in the entire United States. If they didn't like the show, it got canceled.
I remember seeing something like that.
Yeah. Like, that's how they determined it.
They still have it. I just don't think they value it.
They do still have it. Actually, it's done differently now.
Yeah, my brother-in-law got to have to do it.
Yeah, it was crazy. I'm like, all these years I found like, yes, I'm finally in the Nielsen family. They actually have it's a voice, it's a sound recorder. They actually basically it catches with certain signals from TV, radio, and Netflix and all those things. So when you're watching a show, there's actually there's a sound wave that's in the behind that you can't hear that will be picked up by this device to tell what you're watching. And that's how they determine who's watching things. It's still used quite often for like broadcast TV and broadcast radio and satellite radio and those type of things because they don't have a way to figure out exactly who's watching what channel at that point. Your streaming services and stuff like that, you have to log into. So they know exactly who's watching it, how long you're watching it, what you're watching, when you stop, everything else. So they don't necessarily need Nielsen to do that stuff. They have their own ways to actually determine what you're watching. So if Netflix wants to figure out if a show is going to stay on the air or not, do they need to collect sample data or do they have the population data?
Have all the data already.
They have all the data. They have population data. They don't even need to look at samples. They know every single account and what everybody's watching at all times. Okay. So in that situation, we don't necessarily need samples. We have full data. Okay. However, if Channel 3 wants to know what you're watching, they have to take samples because they have no way to know because you're not logging into their service to be able to use it. Now you know why everybody wants you to go to streaming services and to log into things because they get more of your data. Okay. Which allows them to sell ads and make money. All right, so let's look at this. Read the question or read the statement, and then we'll go through the questions. What's the population? What is it? Yes, your population is boys. Okay, so up to the age of 18. That is your population. What is this? I'm going to skip B for a second. What is the sample? Right. In this case, the 1,000 boys that are randomly selected, that is the sample. What's the characteristic being measured? In this case, we're looking at heights. So that's the characteristic. All right. So we have the parameter for the population to be heights, and then it would be a statistic for the sample, would also be heights. Okay. I haven't talked about these yet, but let's see if we could figure it out. Is the data collection descriptive or inferential? Why? What do you think it means?
Because it's a link looking into one characteristic. Like, it's
Okay.
not looking at multiple different things based on culture.
Okay. Anybody else have an idea? Yeah. Okay. What's the goal of me collecting this information?
See if you're at or below the average.
Okay. So, how many people in here have kids? Okay. When you go to the doctor's office with your kid, or when you used to go to the doctor's office with your kid, depending on how old the kids are, what is one of the things they always looked at to tell you about your child?
Their height,
Their height and their weight, right? Where do you think that chart came from? This type of data. Okay. We're going to talk about percentiles and stuff later on. It's the one chart you don't want to be at the 95th percentile. You really want to be 50. You want to be average height and average weight. You don't want to be in the 95th percentile of your weight. Height's different. Like you could be tall and stuff like that. That's fine. But you definitely don't want to be at the 95th percentile of your weight because that means you're heavy. And you don't want to be at the low end either because that means you're underweight. So it's the one time you don't want to be like have a really high percentage. So when you're looking at descriptive and inferential statistics, so a descriptive statistic is the collection and organization of and presentation of data. Okay, so if I'm just going to collect a bunch of data and present that data, that's descriptive. Okay. If I'm going to then take that data and use it to infer something else about the population, that's inferential. So the way the question was worded, they didn't really tell you what they were doing with the data. So we can't really make a determination if it was descriptive versus inferential. If they're going to take the data from that 1,000 boys and say that the average height of the 1,000 boys was 52 inches, okay, when they were 16, and 24 inches when they were 2, for example. Okay, that would be descriptive. However, if they took that data and made that growth chart and was making a prediction about what the entire population of boys were, that would be inferential. Okay. Does that make sense, the difference between the two? Yes, no. I don't mind no as an answer. Just means I need to explain it a little differently. This right here is going to be the key to the vast majority of stuff that we're going to be looking at in this class. We're going to start talking a lot about descriptive statistics. We're going to look at making the bell, or not the bell curves. We're going to make pie charts and bar charts and histograms and those type of things when we're looking at the data. That's all descriptive. Inferential is what really statistics, that's the bread and butter statistics. That's what makes statistics so powerful, is when we collect that information on those 3,000 Americans and then determine what the entire population of the United States believes. Or when we collect the information on those 500 Nielsen families and determine what everybody in the United States wants to watch on TV. Okay. So have you ever heard the statement, well, back then everybody believed the same things and we all liked the same type of stuff. So when people are talking about the good old days, right? Everybody believed the same thing and everything else. Well, that's because they didn't talk to everybody. Okay. So that's where being able to collect the information and everything else now and having a wider variety of information we collect, we get a better understanding of what everybody wants. But that's that inferential. Is inferential statistics always going to be correct? No. Because, as you said at the beginning, people are assholes. People lie a lot, especially when they have an unpopular opinion. Okay? A great example of this was in 2016. All right. Depending on how old you are, depends on how much you remember from 2016. And that was pre-COVID, which means our brains have totally been fried after that point. In 2016, before the election, everybody, every news agency, every poll, every possible thing that came out, Hillary Clinton was winning the election. It was no question in anybody's mind that Hillary Clinton was going to win the election in 2016. Election night came and Trump won. And everybody was like, why? So the main reason why is because when people called up to ask that question, the people that were going to vote for Trump lied. Because the popular opinion that everybody wanted was that Clinton was going to win. So they either didn't answer the question or stated they were voting for Hillary even though they didn't want to. Because that was the answer that they thought the people wanted to hear. But when they got into the voting booths, when nobody was going to know what they said, and nobody knew who they were, they could vote what they really wanted. So when you're collecting information about people, you have to understand that that is a possibility, that they're going to lie to you, especially if they think you can identify who they are. Okay. So even if you say, oh, this is anonymous data and everything else, you're talking to them. They don't know that. So you have to take those things into consideration when you're collecting that information and when you're trying to determine what's going to happen down the line. And that's one of the fallacies and stuff that we have when we're looking at inferential statistics is it is only as good as the data that we're giving it. The whole concept of garbage in, garbage out, that's the concept with inferential statistics. If we put a bunch of garbage data in, the answer we get out is not going to be what we need. Okay. So there's ways around that, and there's ways that we can deal with those situations, but it is a unfortunate risk when we're dealing with statistics. Whereas the Oakland Athletics found out they still can't win the World Series knowing all that information. All right, let's look at this one. What's the population? Yeah. Car accidents. What's the characteristic that we're measuring? Yeah, just the region. The region. We don't want to know where the car accident happened. Okay, which sounds weird. It's like, okay, like that's not really like what you'd really want out of it. Maybe how much money it costs, stuff like that. But in this case, he's literally just looking at what the region is. Name is by region for his company. That's it. All right, what's the sample? He selected 50 of them. Okay. Is the purpose of the data collection descriptive or inferential? And they give you information in the problem to state which one it is. There's only one correct answer to this problem, unlike the last one.
I think it's inferential
Why?
because he's only collecting data from 50 cars.
Okay.
I don't know.
I think it's descriptive,
Why?
because he's not making it a guess, he's just using the data he has. He's not inferring anything.
Okay. All right. One of the things you're going to learn about me real quick, even if you tell me the wrong answer, I'm going to ask you why. If you tell me the right answer, I'm going to ask you why. So do not ever assume when I ask the question why that you are wrong. Okay. I ask why because I want to know your thinking behind what your answer is. Okay. So there's one sentence in this problem that gives you the reason of which one it is. Okay. The last sentence tells you the information you need to determine which one it is.
Summarizing.
He's just summarizing the data that he collected. Okay. That means this is a descriptive statistic. Okay. Nowhere in it does he say he's inferring information about the population. All right. He's just summarizing the counts. Yes.
If it had like, would you also be able to know by saying like you put it into cars and do the
Yeah, but sometimes you can put it into a chart and then you can use that to determine like the rest of the stuff afterwards. So by he's just saying summarizing the counts, he's just giving you a chart with the numbers on it. If he said he then turned into a percentage to say that the percentage of all accidents happen, like 20% of all the accidents happen in the Northeast, that would then be inferred. Okay, because he's selecting the data on 50 accidents, but then he's saying out of all the accidents, 20% happen in the north region. That would be the infer. So since he's just summarizing the counts in the chart, he's not really doing any inferring. Okay, so that's the things you want to look for. And in the assignment that you're having on Hawks, those are some of the things that it's. I told my classes last year and everything else, the number one problem that you're going to have in this class is not math. Honestly, the math that you're going to do in this class is very easy. The hardest thing you're going to have in this problem in this class is English. It's how things are worded that is going to screw up most of it. Okay, it's how they're asking a question that's going to mess things up. The math with calculators and everything else I'm going to show you will be very easy. So if you're math phobic and hate math and everything else, you're going to do fine in this class. Don't freak out because I will make the math simple because when you go out, that's how you're going to do it anyway. All right. It's the questioning and how they're wording it and those type of things that's going to be trouble. And that's like this question here. It's like, how do you determine which one it is in that situation? All right. What about this question? In a study, seatbelt users were found to have 20% fewer fatalities than those who did not wear seatbelts. Did they do a sample or did they do an entire population? Yeah, they did a sample. When they say in a study, they're looking at a sample. They're not looking at all the data. So the question is, do these results prove that seatbelts reduce the chances of fatality? Good answer. Do you have enough data to say that? Absolutely. No. It's a good idea. It's the statement there, 20% is a significant amount, but without other information, we don't know. Who did the survey? Don't know. Okay. It could be a car manufacturer that wants to sell automatic seatbelts. Don't know. All right. When you're given information, okay, one of the things that is very important, and hopefully by the end of this class, like I said, understanding where statistics and stuff come from, but also being very critical when somebody gives you information. All right. Asking very good questions about that information they gave you. I think that's going to be the more important thing, because that's probably the worst thing that we have in society today. Is you're seeing more numbers and more data every single day than you ever have in your life. The question is where is it coming from and who's collecting it and why are they telling you it? All right. So when we went through the pandemic in 2020, we saw all this information and data coming out about COVID and the vaccines and everything else. And you got bombarded with people on both sides saying one thing and saying the other thing. And it's like, who do you believe? Who's actually would be the trustworthy ones that you'd want to look at? And honestly, none of them were. But you have to start looking at like where the actual data and stuff was coming from. So one of the things that I always, when I was looking at the actual data, the one nice thing about being a math teacher and doing statistics is I could actually read the reports that they were putting out and understand them, where most people couldn't. And when they were doing their original studies on the COVID vaccine, whenever you're doing a study, you need to have some kind of a control group. And we'll talk about all this later on down the line. But you have to have a control group, and then you have to have the ones who are taking the vaccine to determine if the vaccine is effective. What they did was, first of all, they took volunteers. So these are people who actually wanted to be in the study, which when you're doing a medical study, you kind of have to have that option. You can't do it on people who don't want to do it. However, the people who are willing to do it were also doing a ton of other things. They were the same people that were socially distancing. They were the same people that were masking and stuff like that. And that skewed the results. That's why when they did the initial tests, it came out and said that the vaccine was like 95% effective. And then when they put it out to everybody, it was only like 70% effective because that changed. And they had a economical reason to say their vaccine was highly effective. The reports were coming from the drug manufacturers. Of course, they wanted to say their vaccine was the most effective because the vaccine that was the most effective was the one that the governments were going to buy and spend money on. Okay? You had a vaccine that came out and said, oh, we're 70% effective, nobody's buying it. Even though that was probably accurate, nobody's buying it. So you need to look at where the data is coming from, because what is the angle and why are they telling you that? All right. The funny thing, the funny statement is math is always true. Statistics is the only math you can lie with. Okay. Because it's all depending on how you interpret the data. So being able to ask those questions and determine that piece is the most important thing in the end that I want you to get out of this class. Is to be able to ask those proper questions. Some of you might go on to become great with people in math and statistics. It's very possible, but probably not the end goal that most of you have right now. All right. Before Wednesday, make sure you log into Hawks. Okay. If you can't get into Hawks Wednesday before class, tell me and we'll get you logged into Hawks. All right. Even if you don't have the code or anything else right now, that's fine. But make sure you get logged into Hawks and we'll check those on Wednesday. Yes. You need the code. You actually don't need the book. You literally need the code. So unfortunately, unless you can find a used book that didn't use the code, you can't find the used book. So yeah, it's one of the downsides to using an online program. The codes can't be used more than once. However, you do have 14 days. So once you log in, you do not need to input the code immediately. It gives you 14 days because financially and all that other stuff. So you have a little bit of time to get the actual code before you log in. All right, stop the recording.